All right, our goal for this lecture is to figure out or just talk about what a fluid is and sort of formalize our thinking about how to think about what a fluid is and what a fluid does. So by the end of this lecture, we should understand exactly what makes a fluid and what types of properties we're interested in understanding. All right, so let's start with our understanding of liquids and gases. I assume that this is something that's pretty intuitive to everybody, but let's formalize it. Okay, what is the difference between a liquid and a gas? There's actually a lot of answers to this question. I think that from the high school point of view and from maybe even an introductory chemistry class, probably the first definition you might have learned is that liquids are something that takes the shape of their container, meaning if I plop a liquid into a bowl, it will basically fill up the bowl until it forms a horizontal line, and all of the liquid will come below the horizontal line. Right? So that's a sort of simple understanding of what liquids are. And of course, typically also liquids also have a higher density, so like the amount of mass per unit volume in a liquid would be a lot bigger than a gas, right? So usually about 1,000-fold bigger, actually. And of course, gases don't behave like that, right? So if I have gas, it doesn't just settle down to the bottom of a container. It just fills up whatever space is available, and if it's not actually in a container and the container is open, it just expands until, basically it's everywhere. So gases basically expand to whatever limits are available to them, bigger than the size of the container, and as such, they're usually a lot less dense, right? So, the density of air is typically 1 kilogram per cubic meter, and the density of water is 1,000 times that big. Okay, but why do they do that? Let's think about that a little bit more carefully. So really what's going on is that, well, of course, liquids are more dense. I don't know if that's a cause or a result, but it is actually a result. So liquids are in a situation where their temperature is such that they are able to strongly, basically condense and strongly interact with one another. So liquids typically have interatomic distance, like the molecules in a liquid will typically have an interatomic distance on the order of 2 angstroms, whereas gases really depend on what pressure they're under, but typically they're, they can be nanometers to hundreds of nanometers apart, depending on what the situation is. And as such, gases don't really strongly interact with each other. They're not bonded to one another, or at the very least, each gas molecule is moving around at thousands of meters per second, and they have enough kinetic energy in a single molecule to overcome any attractions they might feel. And actually what condensation is basically, as soon as they don't have enough kinetic energy to overcome any interactions they have when they touch each other, that's when things start to condense into liquids. In fact, ideal gases, so these are the kind of gases you probably dealt with in thermodynamics. Ideally, gases don't interact at all. They spend most of their time flying around, and they're not close enough to each other to even feel the effects of one another. So that's basically what an ideal gas is, and when the ideal gas law applies, is when, on average, a gas molecule does not see another gas molecule because the attraction distances are just too far away. Also, obviously, in order for a liquid to take the shape of its container, you have to have gravity. That entire idea does not make sense in space.